8,000 meters down, in the deepest scar on the face of the planet, a steel lander is still falling. The pressure gauge keeps climbing. By the time it touches the floor of the Mariana Trench, every square centimeter of that machine is carrying roughly 1,000 atmospheres, the weight of a small car balanced on a single fingernail, everywhere, all at once. It's pitch black. It's a couple of degrees above freezing. By every rule we know about how an animal is built, nothing with a backbone should be able to exist down here. And then the camera light catches something, pale, almost see-through, drifting into the frame without any hurry at all, as if the crushing dark were the most comfortable place in the world. It has skin you can see straight through, a skull that never finishes closing over its own brain, bones so thin they barely deserve the name, eyes that may not actually see. It is not a monster. It's something much stranger than a monster. It's an ordinary animal that has been quietly taken apart and rebuilt from the cells up to survive a place that should kill it instantly. And here's the thing that took scientists the better part of a century to understand. The deep ocean doesn't just get darker as you go down. It gets weirder, and the weirdness isn't random. It follows a rule so strict that somewhere beneath that little fish there is an exact depth where life with a spine simply stops. A line drawn not by predators, not by cold, but by chemistry itself. Today we're going to find that line. In this video, we're going to fall through the ocean floor by floor. We'll meet the forces that take a normal body and bend it into something alien. Pressure, darkness, hunger, and isolation. We'll follow the scientists who read those forces straight out of the bodies of the creatures that survived them, one clue at a time. We'll reach the deepest animal ever filmed on Earth. And finally, the question underneath all of it, the one that turns out to have a real and measurable answer. Is there a bottom to life itself? Let's start with what almost everybody gets wrong. Picture the deep sea, and most of us picture the same thing. Shallow water, but darker. The same kinds of creatures we already know, just dimmer, lonelier, a little spookier. A normal ocean with the lights turned off. The data says almost the exact opposite. When scientists actually measured it, they found that deep-sea fish have roughly twice the variety of body shapes you see in shallow water fish. Twice. The deep isn't a thinned-out version of the surface. It's a workshop building things the surface never dreamed of. It isn't poorer, it's stranger. And what's strangest of all is that nearly all of that strangeness traces back to one single force. As you descend, almost everything stays roughly the same. The temperature barely shifts, the saltiness barely changes. But the pressure never lets up for a second. For every 10 meters you sink, you add about one more atmosphere on top of you. 10 meters, one atmosphere. 10 more, another. It just keeps stacking, relentlessly, all the way down, until at the bottom of the Mariana Trench, you're under more than 1,000 of them. So here's the puzzle that hooked an entire field of biologists. Why would one steadily tightening force make life look alien instead of just making it rare? Why rebuild the animal rather than simply having fewer of them? The first piece of the answer hides inside a molecule that almost nobody has heard of. And the story of how we found it starts, of all places, with the smell of fish. To understand why, you have to understand what pressure actually does to a living thing. It isn't like being squeezed in a fist. It's far sneakier than that. Pressure reaches inside your cells and stiffens the membranes that are supposed to stay soft and flexible. It reaches into your proteins, the tiny molecular machines that run every part of you, and slowly bends them out of the precise shapes they need to work. Imagine trying to thread a needle while a vice tightens, millimeter by millimeter, around your hands. That's life under pressure. Everything still has to function, while the very fabric of your body is being warped. Back in the early 2000s, a marine scientist named Paul Yancey and his colleagues went looking for how deep-sea fish cope with this. And they found something elegant. The deeper a fish lived, the more it was loaded with a particular protective compound. The molecule is called TMAO, and you have actually met it before because TMAO is a big part of what makes fish smell, well, fishy. It turns out this humble little molecule is a kind of molecular bodyguard. It braces proteins from the inside, propping them up against the pressure. holding their shape when the squeeze tries to take it away. And Yancey's team found that fish stockpile more and more of it the deeper they go. More pressure, more bodyguard. It was a beautiful, clean relationship. But that clean relationship came with a sting in the tail, because if you take that line and follow it down, the amount of TMAO a fish would need keeps rising until you hit a point where its body chemistry would tear itself apart, trying to hold that much. Yancey's numbers pointed to a ceiling, a hard floor for fish, somewhere around 8,200 meters, a depth below which a vertebrate simply could not chemically exist. It was a stunning prediction, a line drawn across the deep ocean by maths alone. There was just one problem. Cameras were already catching fish that seemed perfectly happy living close to it, which meant TMAO on its own could not be the whole story. Something else had to be going on inside these animals, and to find it, scientists turned to the strangest fish of the lot, the one from our cold open. Meet Pseudoliparis swire, the Mariana snailfish. If you want to know what the deep does to a body, you don't need a textbook. You just need to look at this animal honestly, because its whole body is a confession. The see-through, unpigmented skin, the bones that are thin and never fully harden, the skull that, astonishingly, never closes all the way over the brain, the strangely inflated stomach. To our eyes it looks fragile, half-finished, almost sickly, and every single one of those features is a solution. Here's the reveal that reframes the entire animal. Hard, mineralized bone is expensive. It takes energy to build and maintain. And below a certain depth in the ocean, the chemistry of seawater actually starts to dissolve it. So the snailfish made a trade that sounds insane until you think about it. It stopped building a rigid skeleton at all. It went soft. A soft, pliable, water-filled body doesn't fight the pressure. It simply lets the pressure pass straight through, equal, on the inside and the outside. Nothing to crush. What looks like a deformity is actually one of the most efficient designs in the ocean. And this is the part that kept scientists up at night. A soft body and a dose of TMO still weren't enough to explain how this fish lived where it did. It had crossed into territory that the chemistry said should be off limits. The answer to that wasn't in its body at all. It was buried in its genes. So in 2019, and then in even sharper detail a few years later, scientists sequenced the snailfish's entire genome, and reading it was like reading a diary of survival. This animal hadn't just borrowed protection from a molecule, it had rewritten itself. Whole sets of genes for vision and for color, switched off, abandoned, because in total darkness they were just dead weight, the telling detail. It had taken a particular gene, one that helps mop up molecular damage, and copied it so it could better survive the storm of cellular wear and tear that living under pressure creates. Then a researcher named Mackenzie Geringer found the clincher. One of the core enzymes that runs the fish's metabolism, a workhorse protein called LDH, had itself evolved to handle pressure, not the bodyguard molecule around it. The machine itself had been re-engineered from the inside to keep working when the vice tightened. And here's where it goes from a single weird fish to something close to a law of nature. In 2025, a team compared the genomes of 12 different deep-sea fish, species that had reached the deep completely separately on different branches of the tree of life. And in nearly every one of them living below 3,000 meters, they found the very same tiny change in the very same gene called RTF1. Think about what that means. Lineages that had never met, separated by millions of years of evolution, all arrived at the identical molecular answer. The deep ocean wasn't scrambling life at random. It was setting the same equation over and over, and life kept solving it the same way. But all of this, the chemistry, the genes, the soft body, it only buys a fish so much depth, which raises the obvious, irresistible question. If even the cleverest vertebrate has a ceiling, then what on earth is living below it? To find out, we have to keep falling, past the fish, into the deepest water on the planet, and down here, the trench belongs to a different kind of animal entirely. This is Hirondelia gigas. It's an amphipod. Picture a pale, oversized cousin of the little shrimp-like creatures that scuttle under rocks at the beach. Except this one was pulled up from 10,929 meters. The very bottom of Challenger Deep, the single deepest point in any ocean on Earth. How does it make a living where almost nothing falls from above? It cheats brilliantly. It carries an enzyme that lets it digest wood. Actual wood. The scraps of trees and plants that drift down from the distant surface and settle in the trench. And then there's the detail that sounds like science fiction. This animal coats itself in a gel rich in aluminium, which it brews out of the very mud of the trench floor. A homemade suit of armor against the crushing world it lives in. It has company too, the supergiant amphipod Alicella gigantea, which grows to a startling size for its kind. And when scientists read its genome, they found its giant body wired into pathways for surviving starvation and storing fat. Because down here, a meal is a corpse falling out of the dark that might never come. And if you never know when you'll eat again, being big isn't a luxury. It's a battery. This is the moment the word strange stops being an insult and becomes the highest praise. Because not one of these features is an accident. Every single bit of weirdness, the see-through skin, the missing bones, the wood-eating gut, the aluminium armor, the giant fat-storing body, maps perfectly onto one of just three problems: the hunger or the dark. And we still haven't met the strangest residents of all. On the floor of Serena Deep, more than 10,000 meters down, sit things that look like crumpled lumps of sediment. They're alive, and each one is a single cell. One cell as big as your open hand, xenophyrophores. And they spend their slow lives quietly farming particles out of the water, building little islands of structure on an otherwise empty plain, making homes for smaller creatures around them. A single cell, the size of your palm, acting as an entire habitat. And then there's the world you can't even see. In 2025, researchers ran a vast genetic survey of trench sediment, a mountain of data, 92 terabytes of it. And when they tallied up the microbes they'd found, nearly 9 out of every 10 species had never been recorded anywhere on Earth before. An entire hidden biosphere evolving alone in the dark, almost completely unknown to us. Some of it, it turns out, has been hiding inside the animals themselves. Living in the gut of that snailfish is a dominant microbe, Candidatus mycoplasma liparidae, that makes vitamins for its host and even runs its own immune defense system against deep-sea viruses. The snailfish was never surviving down there alone. It brought a chemist with it. So now we have the full set: pressure, darkness, hunger, isolation. We've watched what each one does to a body, which means we're finally ready to go back and find the line, the exact depth where all four forces win. Remember Yancey's prediction. The chemical ceiling for fish, around 8,200 meters. In 2023, off the coast of Japan, a camera lander captured a young snailfish swimming at a depth of around 8,300 meters, the deepest fish ever filmed in the history of the world. And look at where it was. Sitting almost exactly on the line the chemistry had predicted decades earlier, from a molecule that makes fish smell fishy. That is not a coincidence. That is a confirmation. The maths and the camera, working completely independently, agreed on where vertebrate life ends. And below that line, no fish has ever been found, not one. The deepest reaches of the deepest trench on Earth, that final stretch of water down to the very bottom, are a place with a ceiling on backboned life baked directly into the laws of chemistry. The trench belongs only to the soft scavengers, the giant single cells, and the unknown microbes, which gives us at last the answer to the whole mystery. The deep ocean doesn't make life weird out of mischief. It makes life weird because it deletes every ordinary option, one by one, until only the strange solutions are left standing. Soft instead of rigid, blind instead of seeing, patient instead of fast. Strangeness down here isn't a flaw or an accident. Strangeness is simply what survival looks like at the absolute edge of what is physically possible. And that's not just a fact about fish. It matters to us right now, because these animals are a living experiment in the limits of biology. Proof of exactly how far life will bend before it breaks, and a record of every trick it uses to get there. Their genes are a library of solutions to pressure, to starvation, to the kind of cellular damage that also drives aging in our own bodies, and we are only just beginning to learn how to read it. For a long time, we wrote the trenches off as dead space, the boring, barren bottom of the world. They've turned out to be one of the largest unexplored habitats on the planet. An isolated kingdom where most of the residents are still completely new to science. And we are studying it with baited traps and a few minutes of camera footage at a time, which is a little like trying to understand an entire rainforest from one photograph taken at night. Which brings us to the question I know some of you have been holding on to this whole time. If we know so little, then somewhere down there, in the deepest, blackest water, couldn't there be a monster? Some Leviathan we've simply missed. I'm sorry to do this to you, but the very rules we just uncovered forbid it. The fish line. There is nowhere near enough food to fuel something enormous, and the pressure caps the chemistry a large vertebrate would need to hold itself together. The deepest trench on Earth physically cannot feed or build a giant. The truth, though, is so much better than a sea monster. The bottom of our world belongs to a see-through fish, the length of your hand, a single cell, the size of your palm, and a little scavenger in homemade armor. Reality, as usual, outweirds the myth. And here's what I keep coming back to. Every one of these impossible creatures is the visible residue of a body solving a problem that should have had no solution. The deep didn't make them ugly. It made them honest. There's no fat to trim, no decoration, nothing wasted. Every feature is there because, without it, the animal would already be dead. And we cracked all of it, not in one heroic flash of genius, but in fragments. A molecule here, a genome there, a single enzyme, a camera dropped into the dark and hauled back up. Decades apart, scientists who mostly never met, each holding one small piece of the same impossible picture. Until finally it came together. The story isn't even finished. Researchers are mapping seeps in the Mariana system, where methane and hydrogen leak straight out of the rock, hinting at whole communities of life that may not run on sunlight at all, but on raw chemistry, bleeding from the seafloor. A second hidden way to be alive down there. And that is a story for another video. If you made it all the way to the bottom with me, genuinely, thank you. Subscribe and stick around, because there is so much more of this strange, wonderful planet left to fall into. And drop a fish in the comments for the little see-through fish, holding the line at the very edge of the world.